Right, with us here is the most famous section on arithmetic sequences and series. But it's very important for us to take note of a couple of things. But the nth term formula, which is Tn equals a plus n minus 1 into d, and Sn equals n over 2 into 2a plus n minus 1 into d. Right, there is an example that is being given here. The sixth term of an arithmetic progression is 5. The seventh term of this progression is 9. More than the fourth term, find the sum of 20 terms of the AP. And we solve this problem. But we solve this problem in a step-by-step manner that will allow us to break new ground, but also that will allow us to ensure that everything is very, very clear. So stay put. Stay put. Right. Stay put. What? How was I supposed to do this question? So that becomes sort of the question that one must ask themselves to say, but how do we start? How do we solve this question? Where do we begin? Do we begin from the beginning of the question, from the end, etc., etc.? And this is the crux of the solving this problem. So let's get cracking. Let's get started. Right, let's get started. First things first, the sixth term of an arithmetic progression is 5. The seventh term of this progression is 9, more than the fourth term. So this question is about terms, like the sixth term. The sixth term, then the seventh term is 9 more than the fourth term. It's about terms, this. So we're just going to use this formula. But it is at the end asking us to find the sum. So it's just about this formula of the terms, and then we're gonna go to the sum. Okay, now let's write the formula that is gonna work. So what do we do here? We prepare and present a solution to this. How do we prepare a solution to this?
We say Tn equals to a plus negative.
Yes, we write Tn. Tn equals a plus n minus 1 into what? Into the common difference. Okay? And with this said, then what do we do with it? We follow the story to say, what do we do with the formula? They are saying the sixth term of an arithmetic progression is 5. Sixth term, term number 6. So we use that. So we're going to find term number 6. A plus 6 minus 1 into D, which means that T6 is A plus. What is 6 minus 1? It is 5D. But this sixth term is equal to what? Is equal to 5. So term number 6 is equal to 5. More information. So we just have changed the sentence to a mathematical equation. The sixth term of the arithmetic progression is 5. The seventh term of this progression is 9 more than the fourth term. So if we're saying the seventh term of this progression is 9 more than the fourth term, so we're dealing with the seventh term. So we're comparing the seventh term together with what? Together with the fourth term. But we're saying this seventh term is 9 more. So if it is 9 more, it means it is bigger, but it means that this T4 is 9 less. So this T7 is bigger, is 9 more. So to make them equal, we need to add 9 to the side that is less. So we get this equation. And what is T7? T7, according to this, is going to be exactly A plus 7 minus 1 into D. Okay? Tn is A plus n minus 1. So T7 is A plus n minus 1 into D, which is 9 plus. Then you have A plus. Then we have T4. T4 is going to be A plus 4 minus 1 into D. 4 minus 1 into D. Right, so in other words, This one gives us an equation. We call equation 1. Then we're going to focus on equation 2. What is 6? What is 7 minus 1? It's 6. So this is a plus 6d. So it gives us, therefore, a plus 6d is equal to, right, this is 9 plus a. 4 minus 1 is what? Is 3d.
3.
So 9 plus a plus 3d. Okay, we manipulate these things here. If you manipulate these things here, we can transpose the terms. Like you have the a here, move it across. So it becomes a minus a plus. We have the 6d and the 3d. So we have 6d, we move the 3d to the other side, making it minus 3d. And this equals 9. So a minus a is 0, which means you have 3d equals 9, which means that d equals 9 out of 3. 9 out of 3 equals what? Equals 3. Like this. So thus d is equal to 3. Okay. Having obtained d equals 3, what do we do with these here? What do we do with these here? Right, so we're going to consider the fact that we have already got d, but we can get a. So using this equation, a plus 5d equals 5 is equation 1. Using a plus 5d equals 5. A plus 5. What did you get d to be? D is equal to 3.
3.
So put a 3 here, which equals 5. What is 5 by 3? It's 15 equals 5, which means A equals 5 minus 15. What is 5 minus 15?
10. Negative 10.
Negative 10. Hence, A is minus 10 and D is equal to 3. What is the next thing that we need to do here? Now we need to, because now we're just dealing with the terms, we're not done with the question. Because now we use the fact that the 7th term of this progression is 9 more than the 4th. And then now you need to find the sum of 20 terms of the AP. Sum of 20 terms. So now we need to find the sum. To find the sum, you use SN formula, which is this.
Yes.
Right, so the summation, which is twice A plus N minus 1 into the common difference D, which is the sum to 20 terms, which is 20 out of 2, into twice A. What is A? A is minus
A is
10,
negative 10.
which is 20 minus 1. The common difference is what? It's exactly 3,
3.
like so. Which means that the sum to 20 terms is equal to what? Right, the sum to 20 terms is this. And therefore the sum to 20 terms is 300 and what? And 70. Like this. The sum to 20 terms is 370. So we're done with that question. Let's move on to the next question. The next question says evaluate. So the next one is an example. It's an example. So how do we do this example? Okay, the question says evaluate 199 plus 197 plus 195 plus, and so on. 101. You divide everything by 99 plus 97 plus 95 plus 1. What is the answer to this? So we prepare a solution to this. Right, so now we have this particular question. We need to evaluate this one. How do we actually evaluate this one, and what is the answer to this here? Right, so to do this one here, a couple of things then remain extremely important for us to consider here. So we're going to look at the denominator. You can look at any of them. Let's look at the numerator. The numerator is this one, which is 199, 197, 195, and so on. And then you need to find the, okay, it's a sum, this one. So the sum must, you must deal with the first term. What is the first term? 199. Right, and then we must look for whether it's arithmetic or geometric. So we must do T2 minus T1. What is T2, which is 197 minus 199? What is the answer? It's exactly minus 2. Then we're going to do T3 minus T2. What is T3? 195.
195.
What is T2?
197.
197, which is exactly minus 2, which means the common difference is minus 2.
Minus 2.
And so now, moreover, the question that we can ask here, but we also have something called the last term Tn. What is the last term? It's exactly
101.
101. 101. So now, if the last term is known, we have a lot of options. But also, the question becomes, how many terms are here? How many terms are there here? So now we need to find the number of terms. So we're going to use this formula. Okay, what is the last term? The last one is 101. The first one, what is the first term? 199. The common difference is what? Is minus 2, which is 101, 199 minus 2n plus 2. So what is 101 minus 199? It's minus 98. Okay, let's use the, yeah, but there is a 1 here, there's a 2. What is 2 plus 199? Is 201. So now if you have 101 minus 201, what is the answer?
minus
minus 100 is
100
equal
or
to
1 below?
minus 2n.
100.
So which means that you have minus 2n is equal to minus 100. And which means that n is minus 100 divided by minus 2, which is 50. So, and the conclusion, therefore, is that you have n equals 50. Right, so if n is 50, then it means that you can be able to find the sum in two ways. So you can use Sn equals n over 2 into twice a plus n minus 1 into d. Or you can use Sn equals n over 2 into a plus Tn. So which means 50 over 2 into twice a. What is the first term there?
The first term is 199.
199. So that's what you're going to do. You put 199 into 50 minus 1. The common difference is what? Is minus 2.
-2.
And then now you can be able to find S50. Okay? The sum of the first 50 terms. So now also here there is S50, which is 50 out of 2 into the first term. What is the first term? 199. What is the last term?
101.
101. Okay, the answer must be the same. You must just get the answer to this. Right. Let's get the calculator quickly.
The answer is 7500.
Okay, good. Let's just check that one. So you're going to have 50 out of 2 into 2 times 199
Yeah,
plus 50 minus 1, you close into minus 2. Right, 7500. You're getting 7500 as well, right? Which is 7,500. Even if you do this one, you expect to get the same answer here. So we're going to do a check for this part here and do 50 out of 2 into 199 plus 101. You close. Okay, 7,500. So okay, so the answer here is S50, which is 7,000 what? 500. Okay, this is the sum of the top. Now we need to deal with this was the numerator, and then now we're dealing with the denominator. Right, the denominator. How do you deal with the denominator? Right, if you look at the denominator is 99 plus 97 plus 95 plus ... plus 1. 99 plus 97 plus 95 plus ... plus 1. So we need to find the sum here. What is the answer to this? If you add all these things, what is the answer? So now we need to take a couple of things like what is the first term of this? The first term is what? Is 99. And then if you have the first term, we're interested in knowing the number of the terms, but what is the common difference? So we can try and do T2 minus T1. T2 is 97 minus T1 is 99, which is minus 2. T3, T2. The common difference, which means Tn. What is Tn? The last term. The last term is what? Is 1.
Is 1.
The first term is what? Is 99. The common difference is minus 2. Minus 2n plus 2. What is 99 plus 2? It's 101. 1 minus 101.
100.
Minus 100. Which is minus 2n. Okay, want to solve for n. How do you solve for n here? You divide the left by minus 2 and the right. Getting 50 equals n. Which is n over 2 into twice a. So we are dealing with 50 terms. We have 50 out of 2. We have twice a. What is the first term? 99. 50 minus 1 into the common difference. What is the common difference?
-2.
Negative 2. So what is the answer to this?
It's 4,000.
2 times 99 plus 50 minus 1.
Yeah, it's 4,000.
You got 4,000, huh? But now the calculator is giving me 2,500.
Is it? Let's see.
Can you check that?
Let me check. 299 minus 2 negative. That's negative.
Calculator is giving me exactly 2,500.
How is that possible? Okay.
Right, with that said, hence the meaning, therefore, is the hence 199 plus 197 plus 195 plus 101. You divide everything by 99 plus 97 plus 95 plus. Okay. One, which is equal to the top You get 3. Get 3. So in other words, hence this summation here is equal to this quotient is 3. The result after division is 3, and we have solved this problem in detail. Right, we move on to the next question. Another example. The sum of the first three terms of an arithmetic sequence is 30. While their product is 840. Determine right, you need to determine. Okay, as I said, these videos will always be uploaded, and then you can be able to write these things down. You need to write them down in a book that you're going to separate as your notebook. Determine these terms. Part of the learning is repeating these. So you write these as notes, but these things, you need to repeat them. So you study this example in your book, and then you make sure you understand it. You copy the question on a separate piece of paper. See if you can be able to solve this on your own without looking at the answer. If you get something wrong, you check the answer, you repeat the process, you write the question again until you can get the answer on your own. You might need to repeat the question 2 times, 3 times, or more. It doesn't matter. But as long as in the end you understand. Right, the sum of the first 3 terms of an arithmetic sequence is 30, while their product is what? While their product is 840. Determine these terms. So what do we do here?
We use the SN formula.
Most definitely. That's what we need to do. That is what exactly we need to do. So the sum of the first 3 terms of an arithmetic sequence is 30. So we are dealing with the sum. The sum is 30, while their product is 840. So when you multiply them, you get 840. So the question then becomes, find these terms. What do we do here? So the sum of the first 3 terms of an arithmetic sequence is 30. Because these are the first 3 terms.
So T3
So
equals to
it is the sum they're talking about. So the sum formula is this one. Meaning the sum of the first 3 terms. So you have 3 over 2.
Is it 3?
Which is twice a. The first term is a plus 3 minus 1 into the common difference. But this sum is what? is 30. So if you add all of them, you get 30. And so this means, therefore, at this pointer, what do you have? You have 3 out of 2 into twice A plus twice D. A plus D. Divide both left and right by 3. If you divide 30 by 3, you get 10. So this is one equation. And then now, the next thing is now their product is 840. Means that now you are dealing with the terms. And the formula is this. So it's the first 3 terms, T1 is A plus 1 minus 1 into D. 1 minus 1 is 0, which is A. T2 is A plus 2 minus 1 into D, which is A plus D. T3 is A plus 3 minus 1 into D. So now you are multiplying them. So their product, which means that you're going to do T1 times T2 times T3, which is 840. Which means that you have A into. Right, so obviously at this point, if you have the T1, T2, T3 equals 840. A plus D. A plus 2D, which is 840. So this is like one equation. Call this one equation 2. Whereas now equation 1 is A plus D is equal to what? A plus D is 10. And then now this means that A is minus D plus 10. Equation 1. So now what you do, you put 1 into 2. All right. So wherever there is A, you put minus D plus 10. So if you do that, what do you get? So in the place of this A, you're going to put minus D plus 10. So you have minus D plus 10 in the place of A. And then in the place of this A, you also put minus D plus 10 in the place of A. Minus D plus 10, but also there is D. Then in the place of this A, you also put minus D plus 10. Plus twice D, which is equal to 840. So this one cancels out and you have a 10 here. And this one is 10 plus D. Okay. At this point, you can divide both left and right by 10. This 10. Giving 10 minus D into 10 plus D equals 84. And this one you can, is like a difference of two squares. 10 squared minus d squared, because it's just, they just differ by sign these. 10 minus d, 10 plus d, 84. Which is 100 minus 84. Which means that d is plus or minus 4. Right. So that these terms are T1 is A, T2 is A plus D, T3 is A plus twice D. So which means that A is minus D plus 10. So A is minus D plus what? Plus 10. In the place of A, you have minus D plus 10. In the place of A, you have minus D plus 10, which is minus D plus 10. 10. Like this. So which means therefore T1 is minus D plus 10. T2 equals 10. T3 equals 10 plus D. So now there are two instances D equals minus 4. Which means this one is minus into minus 4 plus 10. 10. T3 is 10. Right, so T3 is exactly 10 minus 4. T1, therefore, in this case, the same as 14. T2 is 10. T3 is what? Is 6. T1. Now you're going to use D equals 4. So you put it here. Is minus 4 plus 10. By substitution, 10. T3, 10 plus 4, which is equal to 6. T2 is 10. T3 is 14. So which means that the first three terms, right, hence the first three terms, right, hence the first three terms are 14, 10, 14, 10, 6. Or if you don't consider this one, that's 14, 10, 6, you can start with 6, 10, 14. 6, 10, 14, like this. And therefore, we have solved this problem in detail. We proceed to the next question. Next example. The next example. So now, determine the largest value of n for which the sum of n terms of the series -1 +1 +3 +5 will have a value of less than 48. Determine the largest value of n for which the sum of n terms of the series will have a value less than what? Less than 48. What is the answer to this question? We look at the solution to this. Solution. Right, you need to determine the largest value of n for which the sum determine the largest value of n for which the sum of n terms of the series will have a value of less than 48. Right, so we're dealing with these for which the sum of n terms. So we must find the sum of n terms such that we'll have a value of less than 48. Let's find the summation of this. We're dealing with -1 + 1. So you determine the largest value of n for which the sum to n terms will have a value less than 48. So what is the first term here? Term 2 minus term 1. What is term 2? Term 2 is 1 minus, which is exactly 2. Term 3 minus term 2. Term 3 is 3 minus term 2 is 1, and the difference is 2. The common difference becomes 2. And so with this set, then now we're in a position to analyze this, but analyze this very carefully and say, with this, what do we do now? We need to find the summation of this. So what is the summation? The summation is exactly n over 2 into twice a plus n minus 1 into the common difference d, which means that Sn is n over 2 into twice a plus n minus 1 into d, which is n over 2 into twice a minus 1. D becomes 2, which means that we have this. So which means the summation is n over 2 into. Right, obviously we're dealing with these. Determine the largest value of n for which the sum of the series will have a value less than 48. So we're dealing with a sum less than 48. So this sum is less than 48 and we must solve for n. Right, so what do we do here in a case like this? Right, we distribute, we multiply out here, and this gives us minus twice n plus n squared is less than 48, which is exactly n squared minus 2n. Oops. Right. N squared minus 2n, n squared minus 2n minus 48. N squared minus 2n minus 48 is less than 0. Right, what are the factors of these? It's n minus 8, n plus 6. And then here you need to do the critical values. Critical values are n equals 8, n equals minus 6. So if you consider the values here, right, so if you consider these two, now we're considering parts where if you take an arbitrary number that is smaller than minus 6, maybe minus 10, you put it here. It's going to be minus 10 minus 8, which is minus 18. Minus 10 plus 6, which is minus 4. The product is positive, so it's going to be plus here. Between a negative and a positive, maybe a 0. 0 minus 8 is minus, and 0 plus 6 is a plus, making it negative. Bigger than 8, maybe 10. You put it 10 minus 8, it's a plus, and this is a plus, and that becomes a plus. So as a consequence, what you're getting is that the product of this particular quadratic is negative between these two. And as a consequence, then we have minus 6 is less than n less than 8. So the question obviously has been in this case, if you have minus 6 in that, we agree that n is an element of the set of integers. So determine the largest value of n for which the sum of n terms of the series will have a value of less than 48. So a value of less than 48 will be what here? So now, but you need the largest value of n, the largest value of n. So what is the biggest value of n? So if you look at all the natural numbers between minus 6 and 8, the biggest one, largest value of n, value of n, right, where n is a natural number, is 7. That's the answer. The largest value of n is 7. Because now 7 is the closest to 8, but this number n is strictly less than 8. So, but n, because n is strictly less than 8, it means that it can't be 8, but it can be the sort of the next one smaller than 8, the next natural number smaller than 8, and that is 7. Okay, next question. Another example. Right, in this next example, we're going to look at the fact that the first term of an arithmetic sequence is a plus b, and the second term is a minus b. Find the following. The following in terms of a and b. And then you need to simplify your answers. Simplify your answers. Right, so what do we do here? We actually analyze this question and say, the following.
Are these questions on? Are these the exam question papers from the question papers?
Yes, they're past exam questions, but they've been organized. So we decided to just group them into the questions that will focus on arithmetic, and then there are questions that will be focusing on geometric, and then the other questions that will be focusing on quadratic sequences. So okay, part A. D, the common difference. T10 is 20. The first term of arithmetic sequence is a plus b. The second term is a minus b. Find the following in terms of a and b. Right. Right, look at the solution, because now For part A, we have been told that the first term is what? The first term is
A plus B.
A plus B. Well done. Is A plus B. The second term is what? And the second term is A minus
Second term
B.
is A minus B. B.
Then now you need to find the common difference. And we know very well that the common difference is actually T2 minus T1. So the common difference is T2 minus T1. So which means, therefore, what is T2? Okay, T2 obviously becomes the second term, which is A minus B. The first term is A plus B. A minus B minus A minus B. A minus A, and then this is minus 2B. And then now we've found the common difference in terms of A and B. In particular, it is in terms of B. And then now you need to find the T10, the 10th term. Right, so if they say find T10, T sub 10, so that will be part B. A plus N minus 1 into D, which is A plus 10 minus 1 into D. Which means for part B, T10 is A plus 9D. But now, in terms of A and B, what is the common difference? We found the common difference. We found the common difference to be minus what?
Is negative 2B.
To be minus 2B. So the common difference is minus twice B. What is the first term?
A plus B.
Well done. So you can just do Smartian substitution here. The first term is A plus B. The common difference is minus twice B, which means it is A plus B minus 18B. And T10 is what? A minus 17B. So this is T10. S20. So you have N over 2 twice A plus N minus 1 into D. So we're looking for here S20. Right, S20. So we're going to find S20 here. So S20, which is 20 out of 2.
Are you there?
Please come again.
Okay.
You can hear me, right?
I lost you.
Okay, we had lost
my
me.
screen was blank.
Okay, that's fine. It might just be the network. It might just be the network, but you'll get the recording. The recording does not have any cuts, so the recording is continuous. So you have twice A. The first term is A plus B, right? Plus 20 minus 1 into the common difference is minus 2 what? We found that the common difference is minus 2B. Are we together? So now we continue. So which means that S20 is 20 divided by 2, which is what? 10.
10.
2A plus twice B. Then here you have 20 minus 1. What is 20 minus 1? 19. 19 by 2 is what? Is 38. Meaning that we have minus 38b. So which means that S20 is 10 into 2a minus 36b, like this. So you can distribute and open the brackets, in which case 10 times 2 is what? Is 20. A minus 10 times 36 is what? Is 360b. So this is the sum in terms of A and B. These are past exam questions, but once again, I organized them into the arithmetic type, the geometric type, and the quadratic type, so that there's a bit more time to discuss each subtopic, because these are like subtopics. But to allow sort of for the development of a certain level of understanding, one more example. An example. Right. The sum. The sum to n terms of an arithmetic sequence is given by the formula so that Sn is minus 3n squared plus 63n. Determine determine part A, the first term of the sequence the sum of the first two terms of the sequence. C, the common difference. D, the value or values of n if the sum of n terms is 294. Okay, so here we're looking at the fact that the sum to n terms of an arithmetic sequence is given by these formula. Sn equals minus 3n squared plus 63n, or S subscript n equals minus 3n squared plus 63n. Determine the first term of the sequence. What is the first term?
Negative 3 to negative 3n squared.
Okay, so let's look at the solution. Right, in looking at the solution, first we look at part A. Part A, we're looking for the fact that Sn itself is minus 3n squared plus 63n. S1 is minus 3, 1 squared plus 63, 1 into, now 63 minus 3 is 60. So obviously we're dealing with the first term here. So if you are dealing with the first term, it means therefore the sum of one term, of the term at the beginning. If you take the term at the beginning and you find the sum of that one, is just the first term. So it means therefore the first term is 60. Okay, so that's what we have. The first term of the sequence is 60, and then part B. Part B. The sum of the first two terms of the sequence. What is the sum of the first two terms of the what? Of this particular sequence. So now, part B. So we know that we given Sn equals what? Sn is equal to minus 3n squared plus 63n. So that the sum of the first two terms is minus 2 squared plus 63 times 2. Which is S2 is equal to what? Plus 126. And this is exactly the same as what? 114. So thus we can say the sum of the first two terms is 114. Next one.
Common difference.
All right, so now what is the next question?
The common difference.
The common difference. How do we find the common difference? So to find the common difference, it is very, very easy. It is T2 minus T1. T2 minus T1. So the question becomes, what is T2? Right, first you must find term 2, but to find term 2, you actually can find the sum of the first two terms minus the sum of the first term. So which means therefore the sum of the first two terms we saw that is 114. The sum of the first term we saw that it is 60. And that difference is actually equal to what? 54. So the common difference is T2 minus T1. T2 is 54. T1 is what? 60.
60.
T1 is 60. And the difference is minus 6. Minus 6. So which means the common difference is minus 6. Okay. So that is what we have here. Right, so the next thing now is to, so this is the common difference. Common difference is term 2. So we found term 2 and then term 2 minus term 1. Okay, so hence the common difference is minus 6. Part D. The value of values of n if the sum of n terms is 294. the value or values of n if the sum of n terms is 294. Just look at this one, the part D.
Let's see.
Right, so we are saying the sum is actually 294. But we know that the sum is minus 3n squared. Which is 294. Which is minus 3n squared plus 63. Right. We divided through by negative 3, getting n squared minus 21. Plus 98 equals 0. So the factors here. Factors of n squared are n and n. And factors of 98 are minus 14 and minus 7. Which means that n is 14 or n is 7. And so the question obviously is the value of values of n if the sum of n terms is 294. So we can see therefore that the value of values of n are the ones given. N equals 14 or n equals 7. Right, I must thank you for joining us. I'm going to see you again. I'm going to communicate the time. So this sort of concludes our discussion on the arithmetic progressions. So we're going to be looking at the next thing. I'm going to be looking at physics next, but I'm going to send you the time. Okay.
Okay.
Yeah, so this video is going to be uploaded in the next couple of minutes because I wanted to finish this part for arithmetic progressions. And then the next thing is going to be on physics, next discussion. But I'm going to send you the time because it's going to be today soon. But yeah, I just need to check my load shedding and whatnot. Okay. Please
Okay, no
repeat
problem.
the
Thanks, Sunshine.
questions.
Are you going to do life science as well?
Yes, life sciences as well. Yeah. Okay.
Today,
Right. So
tonight.
yeah. So let me just yeah. So I'm ending this discussion now, but I'm going to send you this video in the next couple of minutes. Then physics is next. Okay.
Okay,
Thanks,
thanks,
Lerato.
Sunshine.
Goodbye, Lerato. Goodbye.
Bye.
Goodbye.